Hi Year 2 Mathematicians! Today we are going to remind you how you can use the make turn strategy, the doubles or near doubles strategy, the partitioning strategy, and recalling your number facts to solve some calculations. Let's look at this calculation on my board. It's 23 add 3 is equal to something. So whatever is on this side of the equation has to be equal to what's on this side of the equation. 23 add 3. I've circled my symbol so that I know I'm making my number bigger. I am adding to it. Whenever you see a calculation, it's always worth spending some time really looking at the numbers and thinking about them and seeing what you can spot. For example, in this calculation, I can see a double. I can see 3 add 3. And I know my doubles really well. I know that 3 add 3 is equal to 6. So 23 add 3 must be 26. So I've used the doubles and near double strategy to solve this calculation. The answer is 26. There is 26 on this side and 26 on this side of my equation.
This equation is 9 add 4 is equal to something. The first thing I'm going to do is circle my operation. It's addition, so that means I know my number is going to get bigger rather than smaller. I'm adding to my number. You might be able to do this equation just by recalling your number facts. You might know 9 and 4 in your head straight away. I'm going to check by making 10. I know that 9 is really close to 10. I know that 9 add 1 equals 10. So I'm going to split my 4 into a 1 that I can add to my 9. And using my number facts, I know that 1 add 3 equals 4. So I've got 3 left over. So now I've got 9 add 1, which is 10. And then 10 add 3. That's really easy for me. I know how to add a number onto 10 really quickly. 10 add 3 is 13. That means 9 add 4 is 13.
So this is our next calculation, and this one looks a little bit different because we've got our blank space here. So something equals 24 take away 3. So the first thing we are going to do is circle, because this time it's take away. So it's 24 take away 3. So I'm going to use my number facts to help me to do this one. So first of all, looking at the ones, I then know that 4 take away 3. I know that fact because I know that equals 1. So therefore I can derive and think, so I know that 4 take away 3 equals 1. So therefore I can do 24 take away 3 equals 21. And now the equation is balanced. It's 21 equals 24 take away 3.
Okay, let's look at this calculation. It's 31 add 27 is equal to something. So I've noticed that I'm adding, and I've noticed that I am adding 2-digit numbers together. So there are two 2-digit numbers. Now, it might be that you are confident in using your number facts to just spot the facts that you can use to solve this 2-digit equation, but partitioning, which means breaking the numbers down into their tens and ones, can also be really helpful to check. So 30 has 1, 2, 3 tens, 31 and 1 1. 27 has 2 tens and 1, 2, 3, 4, 5, 6, 7 ones. So all together, if I'm adding 30 and 20, I have 5 tens, I have 50. And I'm adding my 7 ones and my 1 1, I have 8. 50 and 8, I know that that is 58. So you might want to use a similar type partition strategy to solve a 2-digit, add a 2-digit equation. It's not dissimilar. You can still use your knowledge of your tens and ones if it is a 2-digit subtract a 2-digit equation. So like this one, something is equal to 34 subtract 21. I'm still going to draw the tens and ones of my first number, my biggest number, because as you know, we would always start with our largest number if we're subtracting. I'm not going to draw the tens and ones in 21 because I'm not adding. I'm not putting them together. But from here, I am going to break my 21 down in tens and ones to subtract from my 34. I'm going to subtract 1, and I'm going to subtract 2 tens. And what I'm left with is 1 10 and 3 ones. So my answer is 13. 13 is equal to 34 subtract 21. So that's how you would use partitioning for a 2-digit subtract a 2-digit equation.